In this lecture, we look at the role of monitoring in crowd and event operations. We start by analyzing the strengths and limitations of monitoring technology, because every sensor gives us a different piece of the puzzle. We'll also explore how combining multiple sensor types improves situational awareness. No single technology is perfect, but together they create a much clearer operational picture. New monitoring data should also be integrated into existing processes, so that information doesn't just exist, but it actually supports decision-making. We then move into evaluating the reliability of monitoring systems. Technology can fail, and operators need to understand when to trust the data and when to question it. We'll also introduce the concept of a boiler room setup. A boiler room can be seen as a shadow control room where new tools can be tested without operational risk. And finally, we'll look at how to assess and validate new monitoring tools before deploying them in live operations. But why do we want to perform monitoring? Monitoring is essentially the eyes and ears of crowd management. It gives us real-time insight into what is happening on the ground during the event. These insights can be used as a starting point for short-term forecasting, that is, predicting what will happen in the next minutes or hours. Once we understand what is happening now and what most likely will happen in the future, we can anticipate this future situation. This way, monitoring reduces uncertainty and extends our decision horizon. Instead of reacting to problems, we can act before they escalate. Monitoring draws from several types of data. First, we have crowd-related data, showing us how people are moving and how they are experiencing the space. Examples of crowd-related data are density, flow, counts, speed, queue length, and even mood indicators. Then we have the data related to other modes. Think of vehicles, bicycles, ships, public transport, and shared mobility. All these modes interact and thus affect crowd behavior. And finally, we have contextual data. These contextual data often explain why the crowd behaves the way it does. Examples are weather, transport disruptions, event schedules, social media signals, and interventions. To further distinguish the data streams, we structure data along 3 dimensions: time, space, and granularity. Time can be short-term or long-term. During events, we mostly focus on short-term changes, but some contextual inputs are set for the longer term, such as where people come from. The second dimension, space, can be a single cross-section, a stretch of a route, or an entire village, ranging from very local observations to observations covering a larger area. Granularity refers to the level of detail, ranging from individual trajectories with a lot of information on a single person to aggregated flow patterns with limited information on a crowd. Structuring data this way helps us compare different sources and integrate them into a coherent operational picture. There are many types of sensors that can be used for monitoring, each with their own strengths and weaknesses. CCTV with computer vision provides rich visual information, but can suffer from blind spots or occlusions. Wi-Fi and Bluetooth tracking give us movement patterns, but depend on device penetration. Also, privacy is an issue to be considered carefully. Then infrared and pressure sensors are simple and robust, but limited in detail. Low-energy radio waves can track movement through walls, but require infrastructure. Mobile apps offer high accuracy, but rely on user adoption. And ticketing and access control data show entry and exit patterns. And of course, staff observations remain essential. Humans notice things that sensors may miss. So each sensor contributes a different perspective of monitoring. Because typically no single sensor is sufficient, we use sensor fusion. By combining different sensors and thus data sources, we compensate for weaknesses of individual sensors. For example, CCTV might show a dense crowd, but Wi-Fi data can confirm whether people are moving or stationary. Pressure sensors, on the other hand, may detect a queue forming, while a steward report can explain why. So sensor fusion thus increases accuracy, reduces false alarms, and builds confidence in the operational picture. In the current situation, the operational workflows mostly do not yet include monitoring systems. Information gathering relies in the current situation on staff experience, manual observations, and radio communication. When new data streams arrive, the real challenge is weaving them into how the organization already works. The first step is fitting new data into current processes. So deciding who sees the information, when they see it, what action it should trigger. For example, if a sensor shows live queue length, someone must be responsible for acting on that signal, not just admiring the dashboard. Next comes up updating the decision protocols. If operators used to rely on steward reports, but now receive automated alerts, the protocol needs to reflect that shift. Otherwise, the new data just sits on the screen without influencing decisions. Dashboards only help if they support situational awareness. Integrating them into the control room means making them intuitive. A quick glance should show whether a location is green, amber, or red. That's why aligning outputs with level of service thresholds is essential. And finally, none of this works without people. Operators need to know how to interpret this information and what action it implies. Without that, even the best dashboard becomes background decoration. Integration succeeds when technology, processes, and people move together. However, integrating new information is not always smooth. Data may arrive late or in such large volumes that operators struggle to distinguish signals from noise. Organizations may need training or new workflows to make effective use of the data. The challenge is to turn information into actionable insight and not to overwhelm the team. Technical reliability is one of the quiet challenges in monitoring. Even good sensors have limits. Accuracy can drift, cameras can freeze, a wireless system can get overwhelmed when thousands of devices appear at once. Blind spots are another issue. A camera blocked by a flag or lighting rig can make a busy corridor look empty. And small calibration issues like a shifted camera angle or a software update can distort counts in a subtle way without anyone noticing. The key is not expecting perfection, but knowing where each sensor or monitoring tool is strong and where you need to double check with another source or a steward on the ground. Human trust is often the deciding factor in whether monitoring systems actually influence decisions. It is a trade-off between when operators trust the data and when they trust their experience. Operators sometimes trust the data too much, assuming the system is always right. For example, acting on a density alert even when a steward on the ground reports the area is clear. But the opposite also happens. Some operators trust their experience more than the tools, dismissing alerts because it didn't look busy last year. Both extremes create risk. The real skill lies in balancing the two, using data as a guide, but validating it with judgment, cross-checks, and context. Trust isn't automatic. It grows when operators see that the system consistently reflects reality. That's why building confidence in new tools is just as important as installing them. Decision-making in operations is rarely black and white. Data often comes with uncertainty. A density alert might be real, or it might be a shadow on a camera. That is why operators work with confidence levels, not certainties. The key is to cross-check. A sensor alert, a steward report, and a quick camera glance together paint a clearer picture than any single source. And when the data remains ambiguous, teams rely on escalation protocols, so decisions are made deliberately rather than reactively. Uncertainty is not a failure, it's a normal part of real-time operations. A boiler room is like a rehearsal stage for monitoring systems. It is a parallel control room where new tools can be tested without operational risk. A boiler room allows teams to compare new data with traditional processes and see how well they match. It's a safe space to experiment, to make mistakes, and refine tools before they go live. The goal isn't just technical validation. It's building confidence so operators trust the system when it matters. One of the biggest lessons from boiler room testing is how trust grows when the digital picture matches reality. When operators see that the density map reflects exactly what stewards observe on the ground, confidence rises quickly. This ground truth process turns a new system from something abstract into something reliable. It's not the technology alone that builds trust. It is the repeated experience of seeing it getting things right. A good monitoring interface should feel like a helpful colleague, not a puzzle. Clear visuals, consistent color coding, and simple layouts help operators understand the situation at a glance. Red should always mean pay attention. Green should always mean all good. Moreover, the interface should adapt to the advice and the user's role. When the design is intuitive, operators spend less time interpreting the screen and more time making decisions. To conclude, monitoring is not just a technical system, it's a strategic capability. It strengthens situational awareness, supports the level of service management, and helps teams making better decisions under uncertainty. But technology alone is not enough. Organizations need the right processes, training, and culture to turn data into action. When all of that comes together, monitoring becomes one of the most powerful tools in crowd and event operations.